Hello to everybody in the virtual community. We are starting right now session number 7. The topic of the session is tackling with emerging pollutants and diffuse pollution. I would say as a share of the session, that is really a future priority in our thinking, because this is a very tricky thing. First of all, we need a kind of evidence-based decisions in this regard. We need proportionate approaches and a proper level of activities. And finally, for many emerging pollutants, we need, first of all, a kind of public awareness. What means that we need to translate our research findings into a wording where people around the world understand the problem and see the sensitivity of this issue. To arrange some new facts and findings, it's a pleasure for me to share this session together with my nice colleagues, Natalia Rodriguez and Nicolas Fatin-Rouge. Natalia, please start with introducing yourself, and then Nicolas and me, and then we hand over directly to the presentation. Nicolas, Natalia, sorry.
So good morning to everyone and welcome to the session number 7. I'm Natalia Rodriguez Eugenio. I'm working at the Global Soil Partnership in FAO, in the Food and Agriculture Organization of the United Nations. And I'm specifically working on soil pollution and trying to prepare a global assessment of the status of soil pollution. So for me, this special session is quite interesting, because we are addressing one of the major challenges in the detection, management, and remediation of soil pollution. Contaminants of emerging concern, as just Georg said, need a lot of awareness raising for people to understand what are the main, the new issues. And also diffuse pollution presents a lot of political and technical challenges, because it's very difficult to delimit the areas and to assess the risk of this kind of pollution. So I'm really excited for this session, and I really hope to learn a lot from the presentations. Thank you.
Thank you, Natalia. And I hand over to Nicolas.
Yes, thank you, Jörg. I'm Nicolas Fatin-Rouge, professor at the University of Poitiers in France. And I'm working in soil and water remediation, more especially in for in situ remediation, typically with heavy pollution, heavy industrial pollutions. And so I'm not used with diffuse pollution. And it's very interesting for me to learn about this challenge and how tackle these challenging situations.
Thank you, Nicolas. Sorry, I forgot.
Thank you,
Jörg. I forgot to introduce myself. I'm Jörg Fronstein. I'm working more than 28 years for the German Federal Environment Agency. I'm a member of the Common Forum, and I'm actually work on the PFAS issues, especially on remediation options and so far. Therefore, for me, it's a brilliant topic, and I'm very happy to announce our first speaker. This is Antonella Vecchio. I know Antonella for many, many years over the cooperation in the Common Forum. And Antonella is giving a speech about Porto Scuso, which is one of the most important mega sites in Italy. And she will explain how Italy is going to handle with such big contaminated areas. And I'm happy to listen. Antonella, first of all, keep your time management, because 15 minutes are not really much. So the floor is yours. Don't waste time for, come on.
Thank you, Jörg. Thank you, everybody. And I go quickly to my presentation. As Jörg said, I will show you the long story of Porto Scuso assessment and management. I will introduce this mega site, this big area, the stepwise approach for site assessment, and I will leave some minutes to my colleague Elisa Mariani from University of Sapienza that will show you the second phase of risk assessment that has been made this year in 2020. So we are in southwest Sardinia in the national priority list sites of Sulcis, Iglesiente, Guspinese, and the municipal territory outside the industrial area is about 30 square kilometers and is mainly used for agricultural and pasture purposes and includes 2 towns, Porto Scuso and Parignano, and also a Natura 2000 site, the Boicerbus Lagoon. The big source of heavy metal contamination is the Portovesme Metallurgic Industrial District, but we are also in a big mining district, and so there is also a geochemical natural contribution to the presence of inorganic substances in soil and groundwater. So the long process of assessment started in 2008 and is coming to an end in 2020, so 12 years of assessment and investigation and so on, and research activities. We started with field investigation in 2009, 2010, and the main objective was to investigate the status of environmental matrices, to assess natural background, and to identify the conceptual site model. Then the first stage of risk assessment, simplified approach, in order to identify critical areas needing further investigation. After this phase, a big part of the municipality was declared as uncontaminated. And so redevelopment started with an installation of a big wind park. I think the biggest wind park in Italy. The assessment of food production allowed to have no restriction to food production. And this is a territory of good wine, so the wine is still produced in the Porto Scuso area. Then additional investigation in different steps has been made, focusing on critical pathways in critical area. And then this year, the final second phase detailed risk assessment has been made, and additional not contaminated area has been identified, and also critical area needing risk management actions have been identified. This is the biggest investigation part, including many surface and deep probes, piezometers in the shallow aquifer and the deep aquifer, and also the sampling of agricultural plots, soil and food and vegetables produced, also grass, because there is pasture activities, mainly sheep, for the pecorino cheese. The investigation accounted also for the land use and the risk assessment scenario. So it has been not a regular sampling strategy, but a strategy focused on land use and on following risk assessment. So we, after the investigation, confirmed the diffuse presence of heavy metals in soil in the whole territory, but the trend decreasing with sampling that allowed us to distinguish the contribute from fallout, the example of lead in this slide, from the contribute of natural background, the arsenic in this slide. And also for groundwater, the evaluation of background concentration confirmed that the presence of the inorganic substances in groundwater is associated to natural sources. So in the first phase, the natural background was a crucial element to better focus the following risk assessment. The risk assessment was made as a gradual final sieving approach. So we started from the 30 square kilometers investigated area, and we had a course step, identified areas needing further assessment. Then a final step, focusing on critical pathways on contaminant mobility and so on, allowed us to identify risk areas, areas needing risk management actions. With a so big contaminated area, diffuse contaminated area, we accounted for differences in land uses for human health exposure and geological variability for the soil leaching to groundwater. Regarding the agriculture and pasture use, we made a specific assessment on agriculture and pasture parts to assess the soil to plant uptake pathway. First results identified big portions of the the area of the municipality as uncontaminated in the three different layers: topsoil, surface soils, and deep soil. And no significant risk has been estimated for vegetable and food ingestion. So the yellow areas are the critical areas identified after the first step. But while for topsoil and surface soil, the risk assessment has gave a great contribute to identify non-critical areas, for deep soil is the natural background that allowed us to identify the most important part of non-critical areas. Then additional assessment, better definition of the exposure conditions, and additional field investigation focus it on more detailed distribution of soil contamination, assessment of vapors, of mercury vapors in areas with vapor intrusion risks shown by the first risk assessment stage, and then the mobile fractions of arsenic and lead were estimated for the soil to groundwater leaching pathways together with groundwater monitoring. So after additional investigation and the more detailed distribution, other areas exited from this process, from the second phase, and we focused on critical pathways. So we used direct measure of volatile fractions emissions with sampling the soil gases and fluxes. Here is the scheme of vapor sampling, new transport models for dust emissions, because Porto Scuso is a very windy area, so the dust emission is a critical pathway, new exposure assessment for direct contact, and the use of leaching test data and more detailed assessment on the fractured aquifer has been made. So I will leave the stage to Elisa that will show you the result of this second step.
Good morning. The evaluation of vapor inhalation pathways of mercury was carried out through 3 campaigns, according to several lines of evidence. In 2013 campaigns, the indoor environment risk associated to fluxes are generally high of those associated to gas concentration improvement. The accumulation release of vapors outdoor is probably influenced by local conditions, and the higher risks are registered for indoor exposure. In the October 2017 campaign, the risks associated to soil gas concentration and flux measurements are acceptable. The concentration measured in ambient air confirm the substantial absence of mercury vapors. So the vapor inhalation pathway is not critical, and no action is needed in the related areas. The direct contact with soil and dust inhalation pathways have been evaluated with the same approaches used in the first phase and with new approaches of the evaluation. With the new assessment of soil ingestion, the red areas where the risk is unacceptable are less, because it uses a more realistic exposure parameters. While new dust emission model can consider the relevant contribute of wind erosion. Indeed, in red areas, the risk is unacceptable. In the end, the direct contact and dust inhalation for topsoil are still critical pathways. Soil leaching to groundwater pathway has shown potential impact of surface soil and deep soil, arsenic and lead contamination in red areas. However, groundwater monitoring confirmed compliance with screening values up gradient the industrial district. So, leaching to groundwater is not critical and no action is needed in the related areas.
So I will quickly lead to conclusions. After these final steps, the detailed assessment, only the topsoil layer in some areas need risk management actions. And direct contact and dust inhalation, as Elisa said, are the critical exposure pathways. Potential impact to groundwater resources was not confirmed by groundwater monitoring. And if we come back to the final sieving approach, we can say that we studied for 30 square kilometers potential impacted areas. After the core step, only 3 square kilometers needed additional assessment, and after the last step, less than 0.1 square kilometers need management. So after the wall assessment, the 99% of the potential impacted area can be declared as not contaminated. If you see the previous figures of exceedance of screening values, you can see that 90% was potentially contaminated area. And therefore now the municipality can release this area with no significant risk to human health and environment without any restrictions, and identify the risk management action for these limited pathways in areas that were found not to be critical after the second phase, or plan any remediation work at a very local scale in areas where management actions are not effective or not applicable. Therefore, this overall approach avoided extensive investigation and remediation in a largely diffuse contaminated areas, makes sustainable and effective the water management. And that's all. Thank you for your attention. And I ask you to visit these areas because are very beautiful, good food and good wine.
Okay, Antonella, thank you very much for this very clear and impressive presentation. For the auditorium, we will have the chance to raise questions after all the presentations. We have huge block of time we have for specific questions, so keep in mind and maybe write down your first intention. So for me, it's time to hand over to Luca Alberti. Luca Alberti is also a colleague and know over a couple of years, mostly from international and European projects. And Luca will also present from an Interreg project about statistical and modeling approaches for diffuse pollution, especially in urban areas, in this example about Milano. Luca, The floor is yours.
Okay, I try to share my screen. Can you see it? You hear me? Yes, you can see the screen. Okay. So I put. Okay.
Perfect.
Good morning to everyone. So I'm presenting the Amiga project that was developed in the Interreg project and was developed with the Regione Lombardia. And is a project that runs starting in 2016. It ends in last autumn, so in 2019. And 12 partners participate in mixing research institutions and public authorities. In this map, you can see the countries that participated to the project. The Amiga project focus on the problem of groundwater contamination at full scale. What does it mean, full scale? Full scale is defined by the European Community as a city and the surrounding municipality that are connected on environmental point of view and economical point of view. So the full scale is neither local, so we are not concerning just the brownfield, nor wide as agricultural contamination, for example, diffuse contamination on wide, huge areas. And it needs special tools to investigate, remediate, and manage groundwater contamination at full scale. In a large urban area, many kinds of sources can be responsible of groundwater contamination. And for public authorities, it can be very difficult to apply the polluter pay principle. The three kinds of contamination are linked to point source, so are hotspots corresponding to areas releasing plumes of high concentrations. Then we have multiple point sources that are defined as anthropogenic background contamination level linked to many small unidentified sources. And for example, one example could be chlorinated solvent contamination that very often we have in urban areas. And the last one are non-point sources where the contaminant loads comes from the development of human activities on large areas. And a good example is agriculture with contamination for nitrates, for example. And for the case that we are analyzing in the Amiga project, the problem is that the contamination goes behind the administrative boundaries. So it's not concerning just one municipality, but many municipalities. So the FUA, the functional urban areas. And in particular, the Amiga project tackles the problem of groundwater contamination originating from point source and multiple point sources. That are two kinds of sources, anyway, common in the European Community territory. And so the contamination source located in city core affect the groundwater quality in the hinterlands, or the contamination in the hinterlands can flow downstream and influence the groundwater quality inside the main city. In Italy, we have the main law concerning environmental issues, that is the law 152/06, and it defines the anthropogenic diffuse pollution as the chemical, physical, and biological alteration of environmental matrices and contaminations determined by diffuse sources and not linked to a point source. And this decree, this law, designates regional authorities as the authority that has to recognize and to enact action when such diffuse contamination is identified. So in this area, in order to plan groundwater management, it's necessary to assess the diffuse pollution background levels. And one of the aims of the Amica project was to find a methodology and to test a methodology to identify those values. Milano Fuer represents a good case study for diffuse anthropogenic contamination. Here you can see where is located Milano, and the functional urban areas is this light green area surrounding the city of Milano that is in gray. And Milano and the FUA had a long industrial history since the 50s. Many chlorinated hydrocarbon plumes are still present and overlap with a more diffuse contamination. And many public wells show chlorinated hydrocarbons concentration above the threshold limits, mainly for PCE, TCE, and cycloromethane. And the water network public water network of Milano is fed only through wells. We have some well field that you can see in the map on the right side. And you see that the flow of the groundwater is from north to south and flow inside of the city of Milan. So all the plumes, all the industries that surround or surrounded in the past in the north belt, the city of Milano, can affect the quality of the groundwater extracted by those wells. In Milano, we extract 8,000 liters per second. So it's a really huge quantity of water that we extract. It's really important to protect the quality of such an important resource of water. So we developed this methodology that I show you here in one single slide, but after I show you step by step, that was applied in 2 pilot areas at the end of the total functional urban area. So we start from a wide data set. We had 45,000 chemical data, and we applied cluster analysis and transform model. We combined the cluster analysis, so statistical analysis and transform model, to distinguish point and multiple point sources that both contributed to the contamination of the groundwater system, but we need to treat, to manage the 2 sources in a different way, because we can be able to identify the point source, so who is responsible of a single plumes, but it's impossible or really, really hard to identify multiple point sources, because there are many multiple points that are releasing a low concentration, and it's quite impossible to identify each single each one of those multiple point sources. So starting from this huge hydrochemical data sets, we start with statistical analyzing, and we observe that the cluster analysis is able to separate a series of data that are hotspots from the diffuse part. So I don't know if you can see my mouse. So in the right side, you have the hotspot that are identified by those box plot, and the diffuse values are belonging to the first cluster. Then combining this result, putting this result in a map, so checking where those chemical data are located, and combining with all the documents concerning the industrial sites, the contaminated sites, and so on, it was possible to identify the hotspots. The second step was concerning modeling. So we built a groundwater and transport model through ModelFlow and M3D. We calibrate it, and we were able to identify the plume extension generated by those hotspots that we previously identified. So here you have a map with the main plumes flowing inside of the Milano city. And the model, it was built in a huge data set concerning hydrogeologic information. In this video, you can see just a portion of the model with the 4 main plumes that are flowing inside of the Milano city. These are all the stratigraphic logs that we used. In Milano, we have 2 main aquifers that we call aquifer E and aquifer B, but anyway, it's a multi-layer system. You can see that the B is subdivided by clay lands with the gray colors. And the 2 systems are not separated in north part because the clay layer are missing in the north part. So the aquifer E and the aquifer B are in contact in the north part, you can see here. And when we enter in Milan, we can say there is a subdivision of a separation of the 2 aquifers. So using this model, we were able to identify the plumes. Then we were able to cancel all the data concerning the wells and the monitoring wells that were hit by those plumes, because obviously those plumes are linked to a specific source, to a brownfield, to a hotspot, so we know who is the responsible. So there is a possibility to perform remediation action, hydraulic barriers, and so on. So we are not interested on those data. So we clean the database from those data, and we conserve only the chemical data linked to wells and monitoring wells that are not hit by specific plumes. These are data regarding the diffuse pollution. Using this data, it was possible to prepare maps of diffuse contamination. Here you can see the map of the PCE. And we have, with the blue color or green color in the maps that I will show you after, area where the concentration are under the Italian law limit, that is 1.1 microgram per liter. Then we have the yellow area where the concentration are in between 1.1 and 10 micrograms per liter, and red area with concentration higher than 10 micrograms per liter, where 10 is the limit for drink water. So 1.1 is the limit for remediation actions, and 10 micrograms per liter is the limit for drink water. So what emerged from the analysis of those maps is that it's not correct to define one single value of diffuse contamination for all the functional urban areas, because we have areas that are quite clean, areas that are yellow, so with values that are in between the remediation level and drink threshold limits, and red area with strong diffuse contamination. So we decided to apply a factorial and multivariate analysis in order to define the concentration. And at the end, we obtain those values. So the Regione Lombardia, through a regional decree, defined a new reference threshold for diffuse contamination for the aquifer E, and for the, so where the aquifer E, it means where the 2 aquifers are separated, and for the aquifer EP plus B, so the area positioned north to this blue line, where the 2 aquifers are not separated. So for example, in the Milano aquifer, where we are mainly the aquifer E, we have that the yellow area, the concentration, the new threshold concentration is 5.1, and for the red area is 8.5. So that means that in the Milano functional urban area, now those values, RTDC, substitute the CSC, that are the concentration threshold value of contamination that are defined for remediation action. So that it means that if you have an area where you perform a characterization and you discover that in groundwater you have concentration of 4 micrograms per liter, you have not to remediate the area, because it's recognized that in this area there is a diffuse contamination that could be reached 5.1 micrograms per liter. Okay, concluding, anthropogenic diffuse contamination in functional urban area is surely a challenging problem, and the management require new tools to support the public authorities in planning their activities and actions. The methodology that we developed helps the public authorities in identifying the presence of diffuse contamination, so area where there is diffuse contamination, area where there is not the diffuse contamination, and we developed a methodology able to assess, to define the diffuse pollution background levels. Then, thanks to the methodology, it has been possible to produce map representing the distribution of chlorinated hydrocarbon concentration linked to diffuse pollution. I show you just PCE, but we have also map for TCE and trichloromethane. We define different diffuse background level for different sectors in Milano functional urban area. And we support public authorities in making decisions for future management of the groundwater investigation, and to prioritize the investigation areas, focusing public economic resources in those areas that are likely responsible of diffuse contamination. And then we have to highlight areas where the functional urban area, functional urban area monitoring network should be improved for a better survey in next future. Since 2014, Lombardy region adopted a regional remediation plan, and participating to a previous project that was named Plumes. It was just funded by the region, and then participating to the Amiga project, they were able to define a series of remediation measures. So they can limit the water use where a diffuse contamination was identified, and they decide to monitor the groundwater quality for diffuse contamination. So there is a specific network of monitoring wells that are used to monitor the evolution of this diffusion. And the monitoring activity will allow to verify and update the map remediation threshold during the next years, and evaluate the effects of measures adopted by Region Lombardy. At the end, Region Lombardia wants to study and define in a better way the plumes in order to remediate those areas, and then to solve also the problem of the brownfield and the main plumes that are entering inside of the city of Milano. Here in the last slide, you can find a series of scientific papers where we explain the methodology and the results of the Plumes Amiga project. And with this, I have concluded. I want to thank European Community, Lombardy region, and the Regional Environmental Protection Agency, ARPA, of Lombardy. Thank you very much.
Thank you, Luca, for this nice and very interesting presentation. It is now time to welcome the next presenter, which is Paolo Giandon. Paolo has a degree in agricultural engineering. From 1980, he's working in the field of soil monitoring. Since 213 is the manager of soil monitoring and remediation service of the Environmental Protection Agency of the Veneto region. And it is in charge of increasing the soil quality knowledge in order to assess the impact of pollution activities on soil of the region. You can proceed, Paolo. You can start your presentation.
Yes, thank you. Thank you, Chairman, and good morning to everybody. I'm going to present the results of an investigation that we, from the Environmental Protection Agency of Veneto region, conducted some years ago. I mean from 2010 until 2 years ago. It takes a long time because as you will see, it's I mean a time-spending activity to collect sample and to do analysis. We focused on the main persistent organic pollutants that are known and that are also regulated, but some legislation at international level, also at national levels, and they are dioxins and furans in principle, and then also PCB, the polychlorinated biphenyls, and polycyclic aromatic hydrocarbons. And we focused on them because they are mostly of anthropogenic origin, so they can yes, from that they can indicate which is the level of pollution that we have in the territory. They are also dangerous to human health and environment at high concentration, and they are characterized by high depot affinity and semi-volatility and resistant to degradation. So they are very persistent, and we can find in the soil after many time, and they are so extremely persistent in the environment. So we started in 2011 in order with the aim to increase the knowledge and to find out which are the levels of persistent organic pollutants concentration in soils of our region. And we started a monitoring program all over the regional area, not strictly linked to specific incidental events that are the situation in which mainly we, as an Environmental Protection Agency, take samples of soils to analyze this kind of compounds. The aim was to understand the phenomenon of enrichment that can be due to atmospheric fallout principally, but also by diffuse contamination, for example, by agriculture or other activities that are on the soil. So, starting with the methodology, we selected some potential sources of pollution, and mainly this one that are in the list: waste disposal, combustion plants, high temperature processes, melting and metals processing plants, and urban areas. And we see in this map which are the position of this kind of plants or source of pollution. In the remaining areas, we divided the territory using a sample grid with 100 kilometers, square kilometers area. So we at the end have a density of samples collected of about 1 sample each 100 square kilometers. So the sampling strategy was to have a sample from an area. So the area was of about 4,000 square meters, and about 15 subsamples was collected to form the sample that was analyzed in the laboratory. The sampling depth was different depending on soil use. Always a topsoil sample was collected, but also in agricultural soil the sample was collected in the plowed horizon, as we can define as a surface sample, something like that. But also some deep samples have been collected to see if there was the possibility to have some leaching of these substances. Regarding analysis, we also determined some general characteristics of soils in order to investigate if there is some relationship between the type of soil and the concentration of the compounds. So we determined also pH, textures, organic carbon, limestone, heavy metals, and so on. From a data processing point of view, we use descriptive statistics just to have a general picture of the results, but we also then do some tests for normality and correlation and some outliers analysis in order to have a more stable data for coming from have more precise and realistic conclusion. So coming to the results, the first target substances was dioxins and furans. So as we see, about 150 samples collected, and we found that about 50% of samples have concentration lower than 0.5 nanograms per kilos of toxicity equivalence. And it's a value that is very close to the detection limit, so very low values of concentration. In the class of values above 5 nanograms per kilo, only few samples occur. As you see from this graphic, you can see that 50% under 0.5 and only one sample that is between 10 and 12. In Italy, we have a limit for residential areas that is 10 nanograms per kilo. So you see that in general, we had very low concentration of dioxins and furans. We also did some analysis of data analysis about the fingerprint, and particularly to see which cogeners was more frequently present in the samples. And as you can see, principally the 7 and 8 chloride substitute compost cogeners, sorry, was present, and this is also for all the population we analyzed, and both for agricultural soil. So we see that there are very few effect of other potential source of pollution. I mean, the sites, the industrial sites we saw before are not very influencing the concentration we find, and in particular the fingerprint. So at the end, we defined some threshold. We want to name it critical threshold, but they have the significance of value beyond which further investigation is needed. It means that if we have values that are less of these critical thresholds, you are in a very clean situation. Otherwise, you can decide to have more investigation to see which could be the problem for enrichment. So you see that starting from agricultural soils going to soils near waste incinerators, we have some different values from 1.1 to 3.8. Coming to PCB, the polychlorinated biphenyls, we analyzed about 130 samples. And also here, the results were very, with the data, the concentration were very low, as you can see here. About the more than, I see, 90% of the samples collected had a concentration that is lower of 5 microgram per kilo. So we can see here also that looking at the cogeners, the dioxin-like PCB have the lowest concentration if compared with the other cogeners. So confirming a very good situation regarding the potential pollution of soils. Also for PCB, we could define these critical thresholds, and these are the numbers that we found and divided between agricultural soils near foundries, urban and forest soils, from 4 to up to 12.4 microgram per kilos. And the last compound is polycyclic aromatic hydrocarbons. So here we find also a better, better situation. 130 samples about also here for PAH, and no exceedance of Italian law limits was observed. Only 1/3 of the total showed a detectable concentration, so it means that 2/3 was under this detectable limit. And only 13 samples have concentration greater than 0.1. You have to think that to take into account that the low limit is 10, so we have very, very low concentration detected. So coming at conclusions, we can say that low concentration of persistent organic pollutants in soil of Veneto region, if compared with the Italian regulatory limits. For dioxin and furans, quite old samples range between 0.1 and 5 nanogram per kilo. Regarding PCBs, we find always concentration between 1 and 30 microgram per kilos, and for PAHs, only 1/3 of the total sample showed a detectable concentration. All data were always under 10 milligram per kilo. And the critical thresholds, we think that could be effective tool in order to highlight specific enrichment of these substances. Last, future developments about this. After 10 years from the beginning of the first monitoring program, we are now programming a second step in order to come back to the same sites and find out if there could be some changes or the situation is stable and the same of we already see before. Thank you for your attention.
Yeah, thank you very much, Paolo, for this nice presentation. Here we see how near we are between the hotspot and the diffuse pollution, and therefore many approaches can be handled somehow in relation to. The next presentation will bring in another component. This is directed from the Industrial Emission Directive. We know that the Commission did a lot of effort to bring in new instruments in the procedure, which are also touching our management of sites. And from the typical contaminants we are discussing in the process, the idea is enlarging the number which are referred in the CLP directive up to 30,000. And we do not have a faintest idea how many of these substances will behave in soil and groundwater. Therefore, it is very important to think about approaches in relation to the implementation of the Industrial Emissions Directive. We have instruments like the baseline report, like the monitoring during the operational phase, and the approaches returning back to the initial state. I'm very keen to hear the Italian approach, and I would like to invite Deborah to give us the presentation about the thoughts in Italy. So the floor is yours.
Good morning to everyone, thank you. And I can try to share the screen. Let's go. Continue.
So sorry for a short delay. Deborah will handle it, I'm quite sure.
Deborah, if you have two screens, it's possible that your presentation will be shown on the other screen. So basically you have to bring it.
But I haven't had a screen.
Okay, so it's not.
My browser don't allow the access to the function of share screen. So I don't know.
Jorg, Natalia, could you make a first round of questions, and in the meanwhile that Deborah would try to solve her problem of connection? We did, I have to say that Deborah connected before in the half an hour before, and we did the check and everything worked. So basically it's to find out what you have done previously. Okay, Jorg and Natalia, and then
Deborah can share her presentation with the desk.
Yeah, Deborah, if you send the presentation through email, maybe we can display it for you, and then you continue the presentation. Is also a possibility.
Okay.
Okay, so in the meantime, we can start with some questions for the previous three presentations that we have before. I'm sure you will have many questions because the presentations were indeed very interesting. So please don't feel shy, raise your hand, and we give you the voice to ask your questions. For starting, I will have a question for Antonella, and then I will pass the floor to my colleagues, my co-chairs. But Antonella, I wonder, I saw on your presentation that the distribution of the critical areas was very patchy on the area. To what do you attribute this distribution? Is because of the wind or the distribution of local sources? Explain a little more, please.
Okay, the critical areas was in the first phase was concentrated in the 2 towns. So it's the exposure, the driving force of the risk areas. In the second phase, indeed, as we went more into detail, especially for dust emission, is the wind combined with the exposure, the main driver for the identification of critical areas. So we have one more area in the urban agglomerate and other areas in the wind directions, so close to the industrial district and to along the main wind direction, which is maestrale, because Sardinia is has this peculiarity.
Okay, Jörg or Nicolas, do you have any question for Antonella?
Yes, I have a general question. I wonder how long is the time needed for this kind of project? Is the time an important parameter regarding the management of such project and the urge of the answer?
The overall work was very has been a long process. Many research projects were financed by the municipality to assess the area, because according to our legislation, maybe 90% of the municipality is a potentially contaminated site. So we asked also to the municipality what they expected from us, from our research, and they wanted to inform the population about the risks and to assess the areas in which they could make intervention. The time is very long, but it's a stratification of different activities, so it's not so easy to manage.
Okay, I checked through the auditorium and I couldn't find any raised hands, so I come forward with my own question. Antonella, as you explained, it is a success finally to reduce a huge area up to a smaller one. However, 0.1 square kilometer is still a big area, and for remediation action and measures, it's challenging, finally. My question is, do you have also in your regulation, in your legal regulation, any additional possibilities to handle such bigger contaminated areas? So far in the Italian presentation, we have heard about the intervention values and so, fully understood, but there might be another opportunity from the regulation side to handle somehow.
Yes, you touched the critical point of our legislation, because we have the distinction legally. Diffuse is not clear origin of contamination. So if you have, like Porto Scuso, a big impacted areas from one source, it is not diffuse legally. It's contaminated, it's point source. But also the presentation from Politecnico di Milano has the same approach. And now we hope that there are some improvements in our legislation. So the Ministry of the Environment is working on a revision of the whole legislation, but the risk, we are working on the risk assessment strategies. So to help, risk assessment and evaluation strategy may help to pass from legal point, legal diffuse, to practical management of large impacted area. And we hope that also the legislation will follow us in our technical inputs. Let's hope.
Okay, thank you for the moment. Unfortunately, I already see not any raised hand, and I also see not any. Okay. So then I have the chance to hand over to this IED presentation. Here, Deborah is touching the IED as well as the REACH regulation. So I keep fingers crossed. Deborah, the floor is yours, and come forward with your presentation.
Thank you, Chair, and good morning, everyone. Sorry for the inconvenience. I'm introducing you my presentation, done in collaboration with my colleague Lorenzo Maiorino, about emerging pollutants, industrial emission directive, and REACH regulation. Next slide. Thank you. First of all, a short introduction on chemicals. Chemicals are an essential component of our daily lives. More than 100,000 different chemicals are on the European market, with new chemicals being introduced each year. They are used in almost all industries and play an important role in all economic sectors. At the same time, some chemicals can severely damage our health and environment. Others could reveal dangerous if not properly used, treated, or controlled as pollutants. Eurostat data indicate that about 7% of chemicals consumed in Europe are hazardous to the environment or human health. Next, please. In Europe, chemicals are covered by over 40 regulations that include two major regulations, REACH, about placing on the market, and CLP, related to hazard classification. There are a number of sector-specific pieces of legislation on, for example, industrial emissions, pesticides and biocides, food additives, pharmaceuticals, and air pollutants. Next. REACH is the cornerstone of European legislation regulating chemicals. It applies in principle to all uses of all substances throughout their whole life cycle, from manufacture to disposal. REACH regulation aims to improve the protection of human health and environment through the identification of the hazards, uses, and risks of chemical substances. This is done by the four processes of REACH, namely the registration, evaluation, authorization, and restriction. REACH also aims to enhance innovation and competitiveness of the European chemicals industry. It also promotes alternative methods for the hazard assessment of substances in order to reduce the number of tests on animals. Next, please. REACH is based on the principle that industry is responsible to identify and manage the risk from chemicals they manufacture, use, or place on the market. The industry shall also provide safety information on the substances. The chemical safety assessment is the instrument to demonstrate that the risk from the exposure to a substance during its manufacture and use is controlled when specific operational conditions and risk management measures are applied. The chemical safety report documents the chemical safety assessment undertaken as part of the REACH registration process, and it's the key source from which the industry provides information to all users of chemicals. It also forms a basis for other REACH processes, including substance evaluation, authorization, and restriction. Next, please. This slide provides an overview on the different elements of the chemical safety assessment in REACH. The first step is to compile and evaluate all available relevant information on the intrinsic properties of the substance, manufacture, use, emission, and exposure. The second step is represented by the assessment of any hazard the substance may present, where the hazard assessment shows that the substance meets the classification criteria as hazardous to the man or the environment. The CSA shall include other steps: the assessment of the emission and exposure of man and environment resulting from manufacture and uses throughout the life cycle of the substance, the so-called exposure assessment. Then the risk characterization following such exposure. The last step is to identify and document the condition of manufacture and use which are needed for controlling the risks to human health and environment. Next step. And in this slide, I'll introduce the integrated system of registration, assessment, and the risk management of chemicals under REACH and CRP. Companies are responsible for gathering information on the property and the uses of the substances they manufacture or import in quantities of 1 ton or more per year. In addition, they are required to assess the hazard and the potential risks of the substance. This information is communicated to European Chemical Agency, ECHA, by the registration dossier. Until now, more than 22 substances are registered under REACH. ECHA and member states evaluate the information submitted by companies in order to examine the quality of a registration dossier and testing proposal, and to clarify whether a given substance poses a risk to human health or the environment. The authorities, the last step, please. The authorities can conclude that a regulatory risk management at European level, such as authorization, restriction, or harmonized classification, is required for a specific substance. Next slide, please. And now I would like to introduce the European legislation on industrial emissions. In order to minimize the pollution of industrial and agricultural activities with high potential environmental impact, the European Commission issued the IPPC Integrated Pollution Prevention and Control Directive, then updated by the IT Industrial Emission Directive. This directive lays down measures designed to regulate emission arising from the activities of large European industries and represent one of the most significant pieces of legislation for industrial sectors. IED covers more than 50,000 industrial installations in Europe and about 5,600 in Italy. All installations covered by the directive must prevent and reduce pollution by applying the best available techniques and address efficient energy use, waste prevention and management, and measure to prevent accident and limit their consequences. The installation can operate only if in possession of a permit and have to comply with the conditions set therein. Next slide. REACH regulation and the Industrial Emission Directive are plain interlinked and represent the milestone of chemicals legislation and industrial pollution control. The two pieces of legislation have in common many aspects, and they deal with chemical substances and their properties. REACH and ID address to prevention of adverse effects of substances on the environment and the human health, providing different instruments to achieve this goal. The integrated approach of the ID entails that the installation is taken into account as a whole. Chemical hazard and the risk assessment is not foreseen, but emission of the installation to the environment are considered. On the other hand, REACH provides information about hazard and risk of the substances, but doesn't deal with process-generate emissions. Next slide. And these are the following good practices which were identified at the national level in relation to dealing with chemical substances in ID permitting and inspection, creating a direct link between ID and REACH in the national legislation to ensure a level playing field, providing good guidance, checklists, and tools for developing a common understanding. And then requiring information about all substances used or manufacturing during the process chain in the permit application, and notification of any change produce a good base for assessing the risk and formulating permit conditions. This should include the submission of safety data sheets, the communication tool used in REACH along the supply chain, and information about substances listed in Annex 14, the authorization list, and Annex 17, the restriction list of REACH. Finally, fostering close cooperation between IUD permitting and inspection authorities and REACH authorities will allow for producing good and harmonized results. Next. Although the implementation of environmental legislation, including IUD and REACH regulation, has led to improvements in environmental quality, many chemicals are not yet commonly monitored, even if they have the potential to enter the environment and cause adverse ecological and human health effects. In addition, emerging contaminants are still detected in treated municipal and industrial effluents that are subsequently discharged to surface waters across Europe. The emerging pollutants are defined as synthetic or naturally occurring chemicals that are not commonly monitored, but which have the potential to enter the environment, causing adverse ecological or human health effects. As a result of the poor understanding of their fate and impacts, these pollutants are currently largely unregulated in and outside Europe. According to Norma Network, more than 700 emerging pollutants, their metabolites and transformation products are listed as present in the European aquatic environment. Next. And coming to conclusion, first of all, scientific information and regulatory action on chemicals continue to evolve, as does the use of chemicals. As a result, it's fundamental to continue to enhance the ways in which new scientific knowledge is incorporated into prioritization schemes. Increasing collaboration with other regulatory and international agencies will expedite improvements and help to identify or avoid common areas of weakness. Strengthening the collaboration and cooperation with enforcement networks operating at regional and national scale with the aim to promote the sharing of best practices, exchange of experience, transfer of knowledge and know-how, and capacity building of experts in different industrial fields. Then stimulating a more integrated and harmonized environmental inspection practice between CERESO, REACH and IUT. All this may contribute to recognize concepts, to track emerging issues, and to prioritize substances requiring further work, such as information gathering, data generation, or risk assessment. Next. Thank you for your attention.
Thank you so much. Nice explanation and interesting. I'm just checking if last speaker is online, but unfortunately I cannot see him. Ah, yeah, he's now online, so I will just ask to put him as a co-host so he can present. And in the meanwhile, we can continue with the questions for the other speakers while we wait Hernando to be uploaded as a co-host.
Oh, Natalia, I will help out. You will check your presenter and I will take over the question for the time being. Yeah, okay? Okay, perfect. So I have still remaining question to Antonella. Thanks again, Antonella, for your answer before. I would like to know, we realized that these source pathway receptor assessment is an important issue as well as for diffuse pollution. How we can, how you in Italy organize sustainability in the meaning if the use of a site or of the region will change after, let's say, 5 or 10 years. This is often the case in urban areas where we have a change of industry, of other use. And in relation to the decision taking before, it might change the situation regarding the relevant pathways and receptors. Do you have any approach for that, Antonella? Oh. Antonella, can you unmute or do you understood my question? Ah. Oh. Unfortunately, she was not on the place, and so I announced the question and nobody will answer. And the idea behind is that we should store information about this decision about the diffuse pollution. If we have a change in future use, we have to consult this information and these decisions to check it out if it is still valid and can be used also for the new approach for reusing a site. So I see the colleague is coming in.
Yeah, indeed, we have Hernando now joining the meeting. Hernando Núñez del Prado is from the Institute of Research on Environmental Science from the National University of Moquegua in Peru. Hernando, I see you are having some problems with your video. Maybe it's better if you stop the video and try to share the presentation.
Okay, hello.
Perfect, we can hear you. Now,
okay, it's a pleasure to talk to you. I have thanks to Rentex organizers, especially to Marco Falconi. I share my presentation. Okay, the title is High Impact Emerging Mining Pollution on the Health of the Arequipa Population in Southern Peru. Yeah, I have some problems, but yeah, it's important it be able to expose this problem of the contamination of the city of Arequipa with particulate matter, atmospheric matter, since the Cerro Verde Mining Company of Freeport McMoran Corporation does nothing to investigate the problem, and the health of the population has been affected. This report of the analysis of the health situations from ACES is a report of 2080 in the Arequipa region, indicates significant increase in morbidity in asthma, SOVA, and IRAS from 2015 and 2019, and exposure increase of more or less 100 mil case when production trips to 360 mil ton per day. This is the location of the city of Arequipa in the southern region of Peru. They have more than 1 million people. In this Google image, you can see the red line limit of the hills of the intrusive rocks batholithic that adjoin the city. In this small mountain range, every morning the photochemical fog can be seen on the right side. The crop fields that are being contaminated with dust from the tailings dam can be seen in green colors on the left side. You can see the ocean, the open pit, and other components of the mine. Yeah, this is only the limit between the city and the components of the project components. This is the big open pit, but you can see it's near the city. We can see environment influence area reference maps. In this picture, you can see the map of the area of influence on the air quality of the mining operations of the Cerro Verde mine. According to environment impact study, there is no criterion to delimit the atmospheric basin created with extraction of materials. This map delimits the area of influence in the landscape of the Cerro Verde mining unit. The dashed lines are the boundaries of the 9 local subbases that can be delimited. This makes up the approximated limit to which the zone of direct influence of the air pollution zone will reach. This is the dashed line, and you have this is a subbasins, but you have in this map the very contaminated limits. And this map shows the limitations of the contamination with particulate matter, PM10, according to the environment impact study. The colors reflect the different levels of concentration of PM10, annual average scenario 2020. The orange-red colors should be the highest rates. As can be seen, the analysis is not very rigorous and of low quality, invalid, not reflect true dispersion of the pollutants. In this case, the map shows the limitation of the contamination with particulate matter PM2.5, according to the environment impact study. The colors reflect the different levels of the concentration of PM2.5, annual average for the scenario 2020. The orange and red colors will be the highest rates. As can be seen, the analysis is not very rigorous and a low quality, and will not reflect the true dispersion of the pollutants. This graph shows the synthesis of the results of the air quality monitoring from 2010 to 2018, reported by the Cerro Verde mining. The annual average of the monitoring of PM2.5. The lines of colors represent the different districts. The dashed line is the limit of the environment quality standard for Peru, 25 micrograms per meter for cubic meter. This graph shows the annual average to PM10 for the neighboring districts of the Cerro Verde mining operations. As can be seen, the level of concentration with respect to particulate matters less than 10 microns widely exceeds the environment quality standards of our country. The dashed line is the limit of the environment quality standard, 50 microgram per cubic meter. This is the limit. All the results surpass the limit. This figure compares results of monitoring carried out by OEF inspection body of Peru. In the first case, they are monitoring for PM10 of 2 points in the district of Socabaya during 5 days, carried out in 2013. No value exceeds the standard of 100. This is 100. On the right side are the monitoring results for PM10 in the same district for 14 days in September 2018. In this case, in 2 days, the environment quality standards of 100 microgram per cubic meter for 20 hours is exceeded. In this case, this graph presents the comparison between the results of the monitoring of years 2013 and 2018 for particulate matter 2.5 in the district of Socabaya. In the first case, there are 2 points during 5 days. There are 4 points, 1, 2, 4 points during 5 days, and the second case is the monitoring carries out during 14 days in 2018. The results show significant difference. While in 2013, 4 days exceed the environment quality standards of 50 micrograms per meter cube. In 1918, all the results are below 50 micrograms per cubic meter. Sociedad Cerro Verde will have to explain what improvements can be implemented if emissions controls, otherwise it would be necessary and think about data manipulation.
Fernando, you have 2 minutes left.
Okay, thank you. This graph presents a synthesis of the main respiratory diseases that mainly afflict the city of Arequipa population. Between the years 2015 and 2019, where high values are shown for respiratory infections. In conclusion, the mining activity has caused the increase of substances such as carbon dioxide and volatile organic compounds from the wastewater treatment plant. These substances participate in photochemical reactions, mainly with radical oxidryl and nitron oxides radicals present in the atmosphere. Aerosol, dust, gases, and PM from operations can also be considered. These reactions are much more intense in the presence of sunlight. Atmosphere rich in ozone are formed It's a beret of reddish round color and generating tropospheric ozone or polycyclic aromatic hydrocarbons of recognized toxic nature for living beings and their environment. Ozono is harmful to humans and plants, and it can cause serious damage to health, such as disease in the respiratory system. Thank you very much.
Thank you very much, Hernando. Very interesting presentation and indeed quite worrying. I would like to now pass again to the question section. We will go back to the question of Jörg to Antonella, and then we continue with the other speakers. So Antonella, do you need Jörg to repeat the question?
Yeah, please.
Okay.
Okay, Antonella, I keep it short. You made your assessment along the source pathway receptor issue also for these large-scale areas. Regarding sustainability, after a reuse of a site, this might change. How you take care about your decision and the information you collected in case of changing the reuse of a site later on?
Yes, we took into account the land use, so all the things that you can do on that land. And so if an area is residential but without buildings, we consider the buildings, even if the building is not present now. So we try to consider all the possible use of the areas, and sometimes maybe some little restrictions probably could be made on buildings, but is better than no building that can be made or no redevelopment. And we are studying with the municipality all these things and how to communicate to the citizens, because the citizens should be aware that they have a slightly contaminated soil with heavy metals, but that no risk to their life is present. So also the communication should be made properly.
Mm-hmm. Thank you, Antonella.
Okay, now we pass to questions for Luca and diffuse contamination of groundwater. I have one question. Luca, are you here? Yes. Okay.
Yes.
Great. I have a question for you. Do you think similar approaches should be applied in other areas of Italy to better understand diffuse groundwater pollution and update Italian threshold values? Because you have to adapt a little bit the threshold values in Milano area. Do you think the whole Italy should be analyzed for checking those threshold values?
Yes, I think that in some areas should be interesting to repeat the exercise, we can say, so repeat the assessment. Lombardy region would like to apply in 2 other areas. I think that you can apply this methodology everywhere, okay? So now we have another project running with the region Lombardia, trying to design the limits of the methodology. For example, you need a lot of data, chemical data. So if you have a few points monitored and a few analyses in last 10 years, has no sense to evaluate the background, those background values. But in the area with high urbanization, with many industries where there is high number of wells, monitoring wells, I think that should be interesting, because in many contaminated sites, brownfield, in Italy we have those limits very, very low, no? So 1.1 for PCE, 1.5 for TCE. So it's quite impossible to reach these values. And so where you have diffuse contamination, you have no chance to reach it. So it would be important to evaluate also for other areas.
Luca, an additional question to you. Have you any observation in comparison from your statistical output to the situation in situ? Is there or how near you are with your statistical modeling to the practical finding rate of contamination in groundwater?
Yes, I have some example in Milano because I know quite well some brownfield contaminated areas. We are very near in the sense, for example, in northeast part, excuse me, there are huge area that is under remediation. And there are concentration of trichloromethane and perchloroethylene. And the concentration, for example, for trichloromethane are under the limits that are now defined by Region Lombardia. And the PCA are very near. In a sense, in this area, the value is about 3 micrograms per liter, the new value established by the Region Lombardia. And the concentration of PCA are around in between 5 and 6, 7 micrograms per liter. Okay, in some cases, it's useful for the owner of the area, you know, in order to reach 1.1, you spend maybe 10 years. If you can reach 5 micrograms per liter, maybe you have the chance that in 3-4 years you conclude your remediation action.
Thank you, Luca.
Thank you, Luca. Nicolas, do you have any question for Luca?
Not only for Luca. I have a general question for every one of the speakers. I wonder, in your opinion, what are the most important technical barriers or obstacles to manage regarding your experience? Maybe we can start with Antonella.
Yes, here I am.
No, I can hear the final part. So in the barrier to reach what?
Oh, the barrier or obstacle to manage regarding your experience in your field.
With diffuse pollution?
Yes.
As I said to you, the first obstacle is legislation in Italy, I mean, because I don't know in other countries, but I think in some other countries it's the same situation, because the legal responsibility is one thing and management is another thing. So if you have a diffuse polluted area, the main objective of the responsible of the administrative procedure is to find the liable person. So and in some cases it's quite difficult to make them understand that it's not, you can find easily the liable person, but you have to manage the contamination. You have to communicate to the population the risks that they have or not have, and also the technical support. So here I have heard very interesting approaches. Also, I know that the Polytechnical study on groundwater, and we used also, we had experience in the site of national interest in Lombardy that are more easily managed with this after this study regarding groundwater contamination. But I think a more close relationship between science, management, and legislation.
Okay, thank you. May we have your opinion, Luca, about this question?
Okay, I think that the one difficulty is you need a lot of data, as I explained before. So in order to apply such a methodology, you need a groundwater model, transport model, and statistical significant data. No, so this is one issue, surely. The other end, you need. Excuse me.
Yes, I suppose you have many collaborators to get all this characterization data, isn't it?
Many collaborators to have?
To get these characterization data.
Well, there is a huge database in Lombardy. So what was done by my collaborators, but also by the Environmental Protection Agency, is to collect all the networks and put all the data all together. So the waterworks managers, the network of Environmental Protection Agency, the network of private company that has remediation action. So putting all those data all together, we were able to have a lot of information. One difficulty that exists in Italy, but I see in the European project everywhere, is the database, because each public institution has its own database. This you lose a lot of time in trying to put all together the data, because for example in regional Lombardia they have one database, Environmental Protection Agency. The different departments has different databases, and if you update one data, okay, no one knows that you updated this data. So I think that one of the next challenging is that you need to have one shared database, WebGIS, for example, to manage all those data.
Okay, thank you. Paolo, do you have some comments about the question?
Yes, yes. In my opinion, the main bias, as you say, is the risk assessment point, because firstly, it is difficult to agree on some values that you can call background values, natural background or not natural background, but yes, to agree on a number that should be the baseline, and then this number that are yes an indicator of pollution, you have to assess if is impacting or not health and environment, and this is the most difficult step, because it involves a lot of different competence and different skills, and also frequently institutions are very, yes, they can I say they wouldn't take any responsibility in fixing and in deciding if there is an impact or not. So they prefer not to proceed or not to establish yes that the situation is no more risk. They prefer to leave yes not all. They prefer not to face the problem at all in many situations. So we need mainly a more strict cooperation between health and environment experts in order to reach a common point of view.
Thank you. Deborah, what is your opinion about that question? I think we lost Deborah.
Deborah has still some problem of connection.
Okay.
Maybe Hernando.
Hernando?
can reply to the question. Hernando, you are mute. We cannot hear you.
No, I don't have questions about this.
Oh, the question was about the obstacle, the barriers you can you have experienced in your work. So what kind of technical barrier to overcome basically in your work?
Well, the problem in Peru is you have a standard very high only for permission to the extractive industries. The last year you have in Roya region only for send the property, the government changed the standard only for sold the property. It's incredible, and the problem is the favorable institutions in the environment sector.
Okay, thank you. Is there any question left?
Yeah, I think we can ask questions to Paolo. Well, we are almost at the end of the session, but I think we can stay for a couple of minutes more and ask some questions to Deborah, Paolo, and Hernando before closing the session. We have about 10 minutes left, okay? So please stay with us and until we close the session. So I have a quick question for Paolo, because I was surprised that despite this a quite industrialized area, the levels of pollutions were quite low. So do you think is a matter of the design of the experiment, or is because the industries in Veneto are implementing containment and emission control measures quite efficiently?
Yes, I think that the containing measures was established, I think, from 20 years ago until now. That maybe we can see the effect now, because this compost, these substances we analyzed, they are persistent, but they are not. Yes, they have a very slow degradation. So during the time, we see that we have yes, we see that the concentration tends to be lower and lower with time. Where we find some problem of pollution, usually it is due to ancient situation, ancient farms, or the presence in the 60s and in the 70 years of the 20th century. So this is the reason why we don't find very high concentration, and we do not face for these substances significant phenomenon of pollution.
Okay, thank you, Jörg. You have any question for Paolo? Jörg, you are mute. We cannot hear you.
Thank you for the hint. I have not a question for Paolo. I would raise a question to Hernando. Hernando, you described very precisely the situation of the situation in the mining area. Do you see any preventionary approaches that the mining operation itself can avoid these kind of concentration in the overburden or in the material which is still left?
Yeah, the limit now, I think the extractive mine of Cerro Verde more or less have a 150 microgram cubic meter for particular matter. The problem is that the mining continued operation and not anything about to control this problem.
Okay.
And you have the results of in the health of people in the neighboring districts. You have a very high increase of respiratory disease.
Mm.
And the problem is from 2 years ago, the reports of the health institutions no present the results of the monitoring, and the problem is what can I do for mitigate this problem?
Mm.
Because now with the COVID crisis, all the contagious and the diseases are very high.
Mm.
And now, for example, in my case, I only with 5 students, I made my research about this problem of mine Cerro Verde mining, of Quellaveco mining, and that's problem is in Peru. I think I wait for the next year we have elections. We change the possibility to have more resilience of institutions, no?
Okay.
And for people.
Thank you, Hernando.
Nicolas, do you want to ask any question to the other speakers?
No, thank you. I think it's more or less the time to close the session. Is there any more question?
I cannot see any question on the chat. The participants were quite shy today, so I think we can close now.
Okay, I want to thank you, my co-chairs, Natalia and Georg, and thank you for the program for the next days to follow in the meeting. There is this afternoon the session 8 about the circular economy and how to apply it in the context of the Green Deal program. So I want to thank everybody to have attended this session, and I say you goodbye and see you later in the afternoon.
Enjoy your
Goodbye,
lunch.
everybody.
Thank you very much.
Thank you very much. See you.
Thank you to the
Bye.
speakers. Thank you.
See you.
Thank you. Bye.
Bye.
I hope to see you in presence next time.
Thank you all, especially the chair and the speakers, and it was a great session. Go to lunch and be here again in half an hour or 40 minutes, if you like.
Thank you, Marco. Great, Marco.
Ciao, Marco. Hey,
Bye bye.
Oh, Marco, see you.
Bye.